Hello dear learners, when you are attending a maths lesson with me, get ready with your pen, book and your calculator. Today we are going to see how to sketch a cubic function. A cubic function is in the form f of x equal to ax cube plus bx square plus cx plus d. Now, in a parabola, you have only one turning point, but in a cubic function can have a maximum two turning point and one point of inflection. So let me show you the shape to explain where is the turning point and point of inflection. If the value of a is positive, then the shape of the graph looks like this. This is the maximum turning point. We call it local maximum. It's also called stationary point. This is the local minimum stationary point. Point of inflection is where the concavity changes. This point is called a point of inflection. It's called a point of inflection. Now, sometimes the graph will only have one turning point. Then that turning point will also be a point of inflection. So it's called a stationary point of inflection. Stationary. Now, some other graph may also look like this. You can't even see whether it's turning. So actually it doesn't have a turning point. It only has a point of inflection. So these are the different types of cubic graphs. So these two are actually special cases. Normally 80% of the question is based on this type of cubic graphs where you have two turning points and one point of inflection. So here one turning point, one point of inflection. Here no turning point, only one point of inflection. So now the same applies if the graph is negative. That means if the value of a is negative, if a less than 0, then the graph goes down first. This will be the shape of the graph. Then if it has only one stationary point, then it will look like this. This point will be the stationary point of inflection. Stationary point of inflection, same thing. Then if there is no turning point, it will be looking like this. It doesn't have any turning point, only point of inflection. So this one is stationary point of inflection. That means one turning point. One turning point, no turning points. Here, two turning points. These are the three situations. Okay. Now to sketch the graph, like any other graph, we are going to use the intercept method. So we will find the x-intercept, y-intercept, then turning points. These are the three things we need, and also the shape. Okay. Let's take one example. Let's learn one sketching before we go to an exam question. sketch the graph of f of x equal to x cube minus x square minus 5x minus 3. That's the question. Okay, let's see how to sketch the graph. So as I told you, we want the x-intercept, y-intercept and stationary points and the shape of the graph. Shape of the graph is not difficult. I already explained. If a is here, the a value is positive, so we are going to have the positive shape here. Let's start with finding the x-intercept. X-intercept means you put y equal to 0. Y means f of x here. F of x equal to 0 gives you x cube minus x square minus 5x minus 3 equal to 0. This is where you need to know how to factorize a cubic polynomial. Okay, you can use different methods to factorize the cubic function. Now here I am going to use the synthetic division, which is the easiest. So to use the synthetic division, first you have to find one factor. In all different methods, if you're using long division also, you have to find one factor first. So let's find one factor. To find one factor, take the constant in the equation, which is minus 3. The factors of minus 3 can be plus or minus 1 or plus or minus 3. So you give any of these four numbers in fx. So let's start by giving 1. So if you give x equal to 1, it's going to be 1 cube minus 1 square minus 5 times 1 minus 3. You will find that the answer is not 0 if you put in the calculator. Because you already have this in the calculator, you change the 1 to negative 1 now. So it's easy, you just put a negative 1 if before 1 in the calculator and check if it's giving you 0. You will see that that is going to give you 0. It means x equal to negative 1 is a solution. That is the meaning of it. That is the meaning of getting 0 when you put x equal to negative 1. Okay, so that means let us use the synthetic division. So in synthetic division, you use that one factor, one solution, which is minus 1, and write the coefficients of the cubic function: 1, negative 1, negative 5, negative 3. Coefficients of the cubic function. Now we are going to start by putting the 1 as it is in the bottom, 1. Now you multiply these two. Negative 1 times 1, negative 1, negative 1 plus negative 1. You add these two now. That gives you negative 2. Negative 2 times negative 1 is positive 2. Add these two now. Negative 5 plus positive 2 is negative 3. Negative 3 times negative 1 will give you positive 3. Negative 3 plus 3 is 0. So the last one must be 0 because you use the solution here. Okay, what you are getting now? What you got now are the coefficients of the quadratic expression ax square plus bx plus c. So this is a, b and c of the quadratic expression. So the a is 1, so the expression is going to be x square minus 2x minus 3. That is the one factor of this cubic function. One factor is already available from the solution. If x equal to negative 1 is a solution, that means x plus 1 is a factor. That is what the factor theorem say. If x equal to negative 1 is a solution, x plus 1 is a factor. So here x plus 1 is one factor. The other factor is x square minus 2x minus 3 equal to 0. So that means now you use factorize once more, that is x plus 1. Factorize the quadratic function. The factors are x minus 3 and x plus 1. That means the final answer is x equal to -1, x equal to 3, or x equal to -1. -1 is repeating. So actually only two answers. The two intercept. Actually we are finding x-intercept here. So the two x-intercepts that we are getting here are -1 and y0, 3 and 0. Two x-intercepts. So we already finished finding the two x-intercept. Let's find the y-intercept now. So y-intercept means you put x equal to 0. When you put x equal to 0 in the function, you will only get the constant there. Okay, y-intercept x equal to 0. That means y equal to -3. When x equal to 0, y is -3 in the function. Okay, so the y-intercept is 0, -3. Now we are left with the stationary points. Stationary points, that is the most important part in the cubic graph. Stationary points are the turning points. Turning points. So you must remember, at the turning point, the derivative is equal to 0. The gradient is 0 at the turning point. That's the meaning of it. Now that means now we need to take the derivative of the function. Let me write the function here for you. F of x equal to x cube minus x square plus, sorry, minus 5x minus 3. That was the fx. So what is f prime x? Therefore f prime x will be 3x square minus 2x minus 5. Remember, we are using the rules of differentiation to find the derivative here. So x cube, the derivative is 3x square by the rule. X square, the derivative is 2x. Derivative of minus 5x is minus 5. Derivative of the constant part is 0. So that is the derivative of fx. So the derivative equal to 0, and now you factorize or you use the formula. You can also use the formula if you are not comfortable with all the factorization. You also use the formula minus b plus or minus square root of b square minus 4ac divided by 2a. That is the formula. So you get the final answer, x equal to 5/3 or x equal to -1. Okay, while you are finding the turning point, this what you have got now is only the x coordinate. Now to find, this is only the x coordinate of the turning point. When the x coordinate of the turning point is 5/3, what is the y coordinate? So you substitute this x value in the equation in f of x. F of x is written here. That is the f of x. It's going to be 5/3 cube minus 5/3 square minus 5 times 5/3 minus 3. So that will give you, when you put this in the calculator, you get negative 256 over 27. The other turning point is negative 1, but you already know, so the y coordinate of the turning point will be, you already actually, this one you got it, this one also as a x-intercept, so you already know the y was 0, but if you have forgotten, you can substitute and see it again, that when you substitute x equal to negative 1, you again get 0. So the two turning points here are 5 over 3 and negative 256 over 27. The other turning point is negative 1, 0. So we finished finding all the points now. What is remaining before you sketch the graph is the shape of the graph. Shape is known by knowing the first coefficient, that a is positive in our case, so it's a is positive, so the shape is the positive shape, goes up first then goes down. This is the shape of the graph. Now when you draw this shape, you also mark the turning points. It's very important. Look at the two turning points. Which turning point will come first? Negative 1 will come first, so this is one turning point. So now you have an idea how your graph looks like and where to turn. So this is 5 over 3 and negative 256 over 27. Now put this in the calculator to see the corresponding decimal. That will help you when you sketch the graph. 1,67, and this is going to be negative 9,48. Okay, now we are going to sketch the graph. Sketching the graph, you don't need any grid, you are just sketching. Draw the x and y axis. This is the x and y. Here is the origin. Now label the important points. Let's go back and see what was the x-intercept and y-intercept. X-intercept was negative 1, 0 and 3, 0. Y-intercept was 0, negative 3. Okay, negative 1 and 3. So let's go and label the negative 1 and 3. Negative 1 here, negative 1. 3, 1 here, 2 here, 3. You don't need to label all other points, only mark the important points. Now the y-intercept was negative 3, so let's mark negative 3 down here. Okay, now we are going to label these two turning points. We already saw the turning points where at negative 1, 0 is already a turning point. The other turning point is 1,67. This is 1, 2, so 1,67 will be here, and negative 9. 1,67 and negative 9, it's below negative 3, so it can be here, the point. So the point is, you either write 5 over 3, you can write, actually it's better to leave it without any rounding off, negative 256. So we use the negative 9,048 only to know the position. When it is negative 9, you know it's below negative 3. Okay, so this is the other turning point. So only because you know this shape of the graph, now you can sketch. So you know it turns here. This is the maximum turning point. Okay, now let's sketch the graph. You already know it turns here. So that is the maximum turning point. Now the graph passes through the intercept and turns here and passes through the y-intercept. That is the graph of f. Label the graph. So that is all about sketching the cubic graph. Okay, let's go to the exam question now. 17.2 17.2, the graph of cubic function with the equation fx equal to x cube minus 3x minus 2 and gx equal to 2x minus 2 is drawn. A and B are the turning points of f. P is the point on G and Q is the point on F such that PQ is perpendicular to the x-axis. Okay, so let's go to the question. Everything is marked in the diagram. Let's go and see what is asked now. Calculate the coordinates of A and B. As you can see, A and B are the turning points here. So now you must know how to find the turning point in a cubic function. As I mentioned in the previous example, f of x is this one. At the turning point, you have to remember at the turning point. Not only for cubic function, even for parabola, you can use this method now. At the turning point, the gradient equal to 0. So the gradient is the derivative. What is the derivative of x cube minus 3x minus 2? It is using the rules of differentiation. It's going to be 3x square minus 3 equal to 0. Now here you can use the simplification different method. Either you take the common factor out. Now it's a difference of squares, so it's x minus 1 and x plus 1 equal to 0. Therefore, the solutions are x equal to 1 or x equal to negative 1. That means the x coordinate of the turning points are x equal to 1 and x equal to negative 1. Now, one turning point, I think it's already on the x-axis. So we got two answers, 1 and negative 1. You can see 1 is the x-coordinate of A, negative 1 is the x-coordinate of A, and 1 is the x-coordinate of B. Negative 1, the y-coordinate is already 0 because it touches the x-axis, the y is 0. Let's find what is the y-coordinate of B now. So when you got the turning points, you can already see that A is negative 1 and 0. But we have to find the y-coordinate of B before we write the coordinate. So for the y-coordinate in f of x, you give x equal to 1. Minus 3 times 1 minus 2. It's minus 4. So the coordinate of B is going to be negative 1, negative 4. So these are the coordinates of A and B. We finished that 4-mark question now. Now 17.2.2, if PQ is perpendicular to the x-axis, calculate the maximum length of PQ. Okay, you look at PQ here. You can see PQ is the distance between the two graphs. It's drawn from the G to F. So it's a vertical distance between the two graphs. Whenever the question is about the vertical distance, it's top graph minus bottom graph. So the length of PQ is top graph minus bottom graph. When it is vertical line, this is how we can find it, where here in this case the top graph is the g of x and the bottom graph is the f of x. So g of x was 2x minus 2, f of x is x cube minus 3x minus 2. So here we write 2x minus 2 minus x cube minus, was it 3x? Let me quickly check up. Minus 2, which is equal to 2x minus 2 minus x cube plus 3x plus 2 when you open the bracket. That will give you, let me write in order, minus x cube, 2x plus 3x will give you 5x, minus 2 and plus 2 cancel each other. So this is the length of PQ. Let me quickly check what was the question. PQ is perpendicular to the x. Calculate the maximum. So this is just the length. Now to find the maximum length of PQ, maximum is actually it's the turning point of this function. So we know that the turning points, at the turning points, the gradients are equal to 0. So the gradient of this function becomes equal to 0. That means actually it's d over dx of PQ is equal to 0. That means negative 3x square plus 5 equal to 0. That is negative 3x square equal to negative 5. Therefore, x square equal to 5 over 3. Therefore, x equal to square root of 5 over 3. Which is equal to 1,29. Therefore, maximum length of PQ is equal to negative. The maximum is when x equal to 1,29. So it's 1,29 cube plus 5 times 1,29. That is the maximum length of PQ. So put in the calculator 1,29 cube plus 5 times 1,29 will give you 4,30. That is the maximum length of PQ. Okay, now the next question here is determine the values of k for which fx equal to k has only two real roots. Only two real roots. Okay, for you to understand that part, let me quickly go to the graph. Okay, roots fx equal to k is always a a horizontal line like this. So now here you can see it cuts the graph in 1, 2, and 3 places, the cubic function. So these values where it cut the graph, these x coordinates are called the roots of this fx equal to that line. So if it passes through, let's say -3 here, so then the equation of that line is f of x equal to minus, what did I say, -2, yeah. So it's going to be fx equal to -2. Now that means at the point fx equal to -2, the graph has 3 roots. In this question now they are saying determine the values of k for which fx equal to k has only 2 real roots. So for us to have 2 real roots, the lines must be at the turning points. Look at this x-axis, for example. At the when the x-axis cut the graph at 2 different points. At this point here, and also at this point. So it has only 2 real roots. Now if you draw another line at this point, at the turning point here, like this, so that one also cut the graph at 2 different points. So if you want 2 real roots, the line must cut the graph at the turning points. So maybe I can also give you a note on that. It's going to be like this. Now for a cubic function, if you have a horizontal lines drawn at the turning points, it will have 2 roots. But if the line is drawn anywhere in the middle, it's going to have a through. Middle means between the two turning points. Now, if it is above the turning, so let me quickly write this as the turning point. Let me say AB, and that let me say this same turning point is CD. So for finding the roots, you use the y coordinate here. If the y is at B, or if the y is at D, then two roots. Now if the y is between, which one is the minimum here? D. Between D and B, then it's going to have a three roots. Now if the y is above B, or if the y is below D, then it's going to have a one real root. Because if you draw any horizontal line here, it's going to cut the graph only once. So these are the three different situations with the roots. So now here the question is asking you about the two real roots. What is the question here? Determine the values of k for which fx equal to k has two real roots. So the answer is the two turning points. That is where it's going to have two real roots. The two turning points are, we just now found the turning points. Where were the turning? Okay, the turning points were -1 and -1 0 and sorry, I made a mistake here. Okay, please pardon me. That mistake was, it was not -1, it's actually here it was +1. Okay. So the two turning points were -1 0 and 184. Look at the y coordinates. So your answer here in that question will be at y equal to 0 or y equal to -4. That is answer to that question. I think it was 17.2.2 the answer. Now the next question. 17.2.4, determine the values of x for which f is concave up. Okay, I think I better write the answer here. So here the answer, two answers were y equal to 0 or y equal to -4. The answer for 17.2.3. For 17.2.4, determine the values of x for which f is concave up. For any function, cubic function f, concave up for f2 prime x greater than 0. Let's take the fx, x cube minus 3x minus 2. The first derivative is 3x squared minus 3. What is going to be the second derivative now? It's going to be 3 times to 6x. So here it's going to be 6x greater than 0. That means x greater than 0. So this is the answer for values of x for which f is concave up. So f is concave up for x greater than 0. 3 marks. So for these three steps. So that's all, question number 7. I hope you understand. If you understand, like, share and subscribe my channel. Thank you very much.